So we want to look at radical inequalities involving radical equations. So we're saying inequalities involving radical equations. Okay. So we'll go straight into examples. And this is theory sheet 6. For some of you, the theory sheet for the University of Zambia. And this is for UK3. So we're looking at question 3. It's one that you're using as example. A. So the question is solve each of the following. Inequalities. A, 10 minus root of 2x plus 7 is less or equal to 3. So the first that you do here is to move this 10 into to the other side. That implies that you're going to remain with negative 2x plus 7 less or equal to 3 minus 10, which becomes negative 2x plus 7 less or equal to negative 7. And then we'll have to square both sides. We have to square both sides. Squaring both sides means that you've multiplied by the negative, so it will affect the inequality. So on the left, you're going to remain with 2x plus 7 greater or equal to, so the inequality changes because we have tempered the negative that was on the other side. And so we have 49 on the right. So 7 goes the other side. So we get 49 minus 7, which is 42. So when you divide by 2, we get x is greater or equal to 21. Now you can test if this is true. Suppose you picked a number that is less than 21. Let's pick a number like 0. So let's pick a number like 0. 0 is less than 21. So can 0 satisfy this equation? So we're going to have 10 minus root 7. So this is indeed less or equal to 3. Is that true? No. So this is not true. Okay, suppose you pick another number that is less than, okay, suppose we pick 1. So we're going to have 10 minus 2 plus 7. This is 10 minus root of 9, which is 10 minus 3. And this is not less or equal to 3. So it means that our interval satisfies the equation. So our solution set is going to be 21 to infinity. 21 is included because we have less or equal to or greater or equal to. So look at the next question, B. So for B, we have 3 less or equal to the root of 2x plus 5, and this is less than 6. So whenever we have this kind of inequality, the radical is bounded. So there's something bounding it on the right and on the left. We can do it simultaneously by squaring all the parts. So we square this part, we also square the middle part, we also square the other part. So we have 9 is less or equal to 2x plus 5, which is less than 36. Then we take this 5 the other side, we also take the 5 the other side. In other words, we subtract 5 from all the three parts. So we have 9 minus 5, which is 4, less or equal to 2x, less than 36 minus 5, we get 31. Then we divide by this 2, we divide by the 2, we divide by the 2, so we get 2 is less or equal to x, which is less than 31 over 2. This is the solution set. So what happens is that if you are dealing with radicals, for radicals, we always go for squaring, because once we square, it means that we get rid of the radicals. So if when you square once, you can't get rid of the radicals, you need to keep squaring until you get rid of the radicals. That's the idea behind these types of questions. So I have C, that is 2x plus 9 minus 9 plus x is greater than 0. So if I take this the other side, I'm going to have 2x plus 9 is greater than 9 plus x. So if we square this, then what we get is 2x plus 9 is greater than 9 plus x. So if we take the 9 that side, we take the x this side, we are going to have 2x minus x is greater than 9 minus 9. This implies that x is greater than 0. So this becomes the solution set. So it's that nice and that easy. Okay, so can we pick another question? D. So it has root 2 minus root x plus 6 less or equal to negative root x. Okay, so the way this one has been phrased, we just start squaring wherever we are. Okay, so we square the other side, we also square the left hand side. So we are going to get 2 minus 2 by x plus 6. So these are going to be 2 of them because again we are still multiplying, and then plus x plus 6. So this should be greater or equal to x. So I've changed the inequality sign there because I've tempered the negative on the right, so that we have 2 minus 2 root of 2x plus 12 is greater or equal to, so I can take this other side so that I have negative 6 only, because x minus x is going to be 0. So if we take these 2 as well, we are going to remain with negative 2 root of 2x plus 12 is greater or equal to negative 8. So if we divide by negative 2, we divide by negative 2, then you are going to have 2x plus 12 is less or equal to positive 4. So that if we square this side, we also square the other side, then we get 2x plus 12 is less or equal to 16. So you can take 12 the other side, so that we have 2x is less or equal to 16 minus 12, we get 4. So if we divide by 2, we divide by 2, x is less or equal to 2, and this is the solution set. So it's this nice. So we do the last question on this part. that is x minus 3 greater than x plus 4 minus 1. So because of its nature, so we'll square the left-hand side, we'll also square the right-hand side. So we are going to have x minus 3 greater than x plus 4 minus 2 x plus 4 plus 1. So I leave the expansion part. So be able to expand the power 2. That's not a big deal there. And then we take all these, we bring them the other side. So that we have x minus x is going to be 0. Because now we're going to have x minus 3 minus 4 minus 1 is greater than minus 2 x plus 4. So that the x's disappear, and so we have negative 8 on the left is greater than negative 2 x plus 4. So if I divide by negative 2, divide by negative 2, what we get is 4 less than x plus 4. So when we square this part, we also square the other side. So we get 16 is less than x plus 4. So notice how I change the inequality every time I multiply with a negative or divide by the negative. So that when this 4 comes the other side, we get 12 is less than x. And so the solution set is x greater than 12, which you can decide to write as 12 to infinity. So you can choose to be writing your answers in that form, so that you can write this one as negative infinity to positive 2. Included, not included. And this one would be 0 to infinity, like that. So that this one can be 2 included, comma, z1 over 2 not included. The other one I've already written in that form. So these were examples and questions on equations involving inequalities involving radical equations. And this was tutorial sheet 6. And Kathleen, we are now moving to tutorial sheet 7 in the next video. Hope you enjoy this. Thank you.